Good morning, DS4HS. Let's get right into it. So today we're going to learn about the Python basics for data science. So let's get right into it. And I'm going to read you guys this quick description in these first two cells before we get on to the hands-on stuff. And like I said, if you guys ever get lost or the pace of this class ever gets too fast, you can just stop the video or go back whenever you want. That's the great thing about these videos. You can stop, go back, look at what we've written on our screen. You're going to be using this video to go through this exact same Jupyter notebook, so don't worry. What we go through is what you go through. And don't feel pressured to keep up. So you can stop this video at any time if you think the pace of this class is going too fast. So let's get into it. Python is classified as an object-oriented programming language and shares concepts found in Java, JavaScript, and C++. Studying the details of object-oriented programming is the subject of computer science rather than data science. Our goal is to learn to use Python as a tool in data science. To do this effectively, it is recommended to learn some object-oriented programming terminology as it relates to Python. Here are some key terms to know. Everything in Python is an object, and every object has a set of attributes. Three key terms of Python objects are: number one, object name. Every Python object is assigned a name. Number two, object type. Every Python object is assigned a type. Common Python types are string, integer, and float. Think of Python types as the equivalent of elements in the periodic table of elements for the Python programming language. Number three, object attributes, specifically object methods. Python methods are specific functions related to a given object using the Python dot notation. Let's make this theory come alive by using our IPython interface inside of this Jupyter notebook. So let's get into the hands-on part. So first, let's start with generating a Python error message. The error message states that the Python object name dog is not defined. Boom, and it does. See right here, it's a name error, so that is the type of error. So there's different types of error. There's syntax error, name error, type error, and the type of error that this is a name error. Okay, and then it shows us with this green line right here. That's the great thing about Jupyter Notebooks. It shows that our problem is found in line 1, and it says name dog is not defined. So if it was defined, let's say dog equals p, and let's make it a string. Boom, see? No error message. But if it wasn't defined, say it was just dog, boom, and it's a name error because it is not defined. And right here, you see these two lines of code in the blue. The reason why they're blue is because they have this little pound sign next to them. And what this pound sign does is it tells Python to ignore it. And that's called commenting. So when you comment something, you put this little pound sign. Ready? So right now it's going to say invalid syntax because we have all this stuff right here. And it's invalid because we have one quote and it's think that it's an incomplete string. But that's not the case. Let's say we don't have that. Boom. Invalid because it says with, and with is a invalid syntax because all this stuff. But it's still invalid because we have all these errors. But if we comment it out, it tells Python to ignore it. Boom. And now it just goes back to dog. Or if we go all the way ahead of dog, let's say we go over here, comment out dog, boom, there's no error because we commented it out and we told Python to ignore it. So yeah, so that's what commenting something out does. And it helps you because you can put notes on code and it won't generate any errors. So here we got dog. Now we retype the word dog and place it in quotes to assign it to the Python string object. Specifically, we have created a Python object. This is classified as a string data type. Boom. See, no errors. And if you don't get an error message, see up here we got an error message. That means we did something wrong. We had an error. But here, if we do Shift Enter, and in order to advance a cell and to execute that cell, execute that code, you just hit Shift Enter. And if you do not get an error message, that means that code is correct and you ran it correctly. We can validate that dog is assigned to the Python string data type with the Python type statement. So boom, we go here and we do type. Let's type it out. Type, and then type you have to do parentheses, and then since it's quotes, dog, D-O-G, shift enter, boom, and it's str, which is short for string. And And that's really great because a string is anything that's encapsulated with quotes. So it can either be single quotes, double quotes, even double quotes. And that's really great. And the good thing about double quotes, why people use double quotes a lot for strings, is so you can use apostrophes and commas and stuff like that, so it won't confuse the code. But that's what a string is. And we can validate that this is a string by doing the type. And yeah, so let's go on to the next one. We can examine the object-oriented programming methods of an object using the dot notation or the period notation. In both IPython or in Jupyter Notebooks, you can use the tab key to access a pop-up window that will display all methods of a specific Python object type. Let's do it with our string dog. So this dot notation, this little period right here, we're going to do it with dog. Ready? Boom. Right now we have the dot notation upper, and what that does is makes every single letter in the string dog uppercase. But when they say right here, you can use the tab key to access a pop-up window. Let's see that pop-up window. So right now we're going to do dot tab and see right here a pop-up window of all the possible methods. So all the possible methods, there's a lot of them. All the possible methods. And then if you type in a letter, let's do T tab. It gives us the two possible methods that start with a T. So let's try title, and with most methods, excuse me, you have to do parentheses at the end in order for them to work. Boom, and it makes the first letter capitalized. So if we said dog house, it's gonna make the first letter of each word capitalized. So the D in dog and the H in house. Boom. But that's the cool thing about using the dot notation. And yeah, so let's go on to the next one. Remember that Jupyter Notebooks is a user-friendly front-end user interface for the under-the-hood IPython programming environment. One of the very nice features of the Jupyter Lab environment is that it allows you to work within a Jupyter Notebook environment or in a direct IPython environment using the Jupyter Lab Terminal tab. Always remember to use all of the resources in Jupyter Lab and more broadly on our Collaborate remote desktop. Since I am using only Jupyter Notebooks on my Mac in this presentation, I will access IPython from my Mac terminal mode. So let's do that right now. Let me access IPython from my Mac terminal mode. So I'm going to go out. Luckily, I have my terminal right here. And right now I'm in basic Linux operating system, but I need to access IPython, so I just type in IPython 3. It needs to load, boom. Oh, I'm sorry, it doesn't need a space. There's an error there. Just IPython 3, all one word. Boom. There we go. Now I'm all good. And see, as you see right here, you have the in1 tells us this line code, just like on the Jupyter Notebooks in here, because IPython runs under the hood of a Jupyter Notebook. And Jupyter Notebooks are kind of like the nurturing way of getting you into the IPython environment. They're like the bubble of IPython. They're very cushy IPython, but this is the real world IPython that you would use. But look, it's the exact same stuff as a Jupyter Notebook. So let's do the dog again. See, dog, and then we can do type. That's going to be the same thing that we had on our Jupyter Notebook. Oh, I forgot a quotation mark. Enter. See, it's a string. Same thing. Let's do dot dog and then do the dot notation. Sorry, quote dog and then do the dot notation. Tab it out, and it shows you everything that we could use. It gives us a pop-up window of all the methods, which is really great. And also you could do type in a letter and do tab, and it shows you right now. For you, there's only one. But let's say for T, there's two: title and translate. But let's do upper, and it's going to do the same thing. Boom, make it all uppercase. So that is really interesting. So IPython runs under the hood, is working behind the scenes in Jupyter Notebooks, and Jupyter Notebooks is IPython. It's just a cushier, more cleaned up version, more user-friendly version than IPython. But IPython is what runs under the hood in Jupyter Notebooks. So let's get back to it. Let's explore 3 more common Python objects encountered in data science: integers, floats, and lists. So right here, we have 10. And here's an integer. you do not need any quotes around an integer. So here you run it, no error message because it's fine. One thing that's really great about Python is you can use Python as a calculator with integers. And you can also use it as a calculator with floats, but we'll get into that later on. Right here, 10 plus 2, you can do anything. You can do 10 plus 2 divided by 2 times 6. Boom, 16. See, and it gives us everything we need. But right here, we made that into a float, and we're going to get into what a float is later on. But let's just do 10 plus 2. So it's 12, and then type 10. Type 10, shift enter. It's an integer. It's an int, int, abbreviation for integer. And then let's do, it can be any number. So let's do negative 19, still an integer. 234. Still an integer. So it can be anything that's a whole number, negative or positive, is an integer. So let's get it into the 10.1. So 10.1 here is a float or a number with a decimal point. So here you do shift enter, and we're going to add 0.5 plus 10.2. Like I said, you can use Python as a calculator with integers, but also with floats, because here is a float. And like we said, a float is a number with a decimal point. So we do shift enter. We can do it with anything. Plus 67.89. Boom. See, it does that math with any float, with any integer. And you can also even add a float with an integer. So I'm going to do a float, 0.5, plus an integer, 10. So 10.5. So yeah, and it makes it a float because obviously there's a 0.5 in it. But also, you can also have whole numbers that are floats if they have a decimal point. So right there, that's a float. And we do type 10.0, even though it's a whole number, it still has a decimal point, which makes it a float. And if we do it, a whole number that's a float plus a whole number that's an integer, it's always going to come out as a float. See, right here, plus 10. Right here, whole number that's a float, whole number that's an integer. We add them together, type, still a float. And that's very interesting stuff. So let's get into the next thing. Every Python object we have worked with so far can be assigned to a variable. So here we have assigned 3 things to a variable. We've assigned the string cat to x. So every time we call x, it's going to come up as cat. We have assigned the integer 10 to y. And we have assigned the float 10.7 to z. So let's run it. So we're going to enter x, y, and z individually in the cell, and press shift enter. Repeat this process. So first, let's start with x. And in order to execute a cell, like I said, you just hit shift enter. And guys, if I'm going too fast, you can stop the video at any time, go back and review. It's really fine. There's really no rush. And if you ever get lost, you can just look at my screen right here in this video and type exactly what I'm typing, because we're going to be working on the exact same notebooks. So shift enter, boom, it's going to come up as cat. Now we're going to do y. What do you think is going to happen as y? Pause the video, and when I do shift enter, what do you think is going to happen? Okay, ready? I'm going to do it 10, because it's 10 is saved to the variable y. Now we're going to do z. What's going to happen to z? Yep, you guessed it, 10.7, because 10.7 is saved to the variable z. Now we're going to check what type each of these variables are. So we're going to check what type x is, what data type y is, what data type z is, and do it individually in this cell, and press shift enter and repeat this process. So first, let's do x. Boom. It's a string, because right here we have cat, which is a string, and that's saved to the variable x. Now let's do y. What do you think y is going to be? If it's 10 with no decimal point, what do you think it's going to be? Exactly, you guessed it, an integer. Boom, and it is an int. And then we're going to do z, and z is 10.7, and it has a decimal point, so you guessed it, it's going to be a float. So if you need to check the data type of something, you do type with parentheses, and then that name of the variable, or the variable itself inside of the parentheses, and it will return what data type it is, which is really, really cool. Now we're going to go to the next one. Here, I'll close this real quick. And we're going to enter question mark x, question mark y, and question mark z all individually, and read the useful online help supplied by Python. Notice the Python object type is listed at the very top of this help message. The doc string gives you more detailed information. So by putting the question mark ahead of the variable really helps you because it gives you an in-depth description. It's a really good thing that IPython does. Is it gives you an in-depth description of the variable, of the object type, of everything. So let's see what happens when we do question mark x. Boom! And it gives us the type. It gives us the type, and it's a string. It shows us that the form is cat because that's what the string is. The length is 3 because it has 3 characters. And it gives us also a lot more in-depth stuff right down here. But it's really great because it gives you an in-depth insight into what that variable is. And it's not just with x, it's with anything. So we'll do it with y, shift enter. And it shows us like that. Ready? It shows us it's an integer. String form is 10 because it is 10. Doc string is 0 because there's no characters right there. And it's also all this other coding stuff, but we'll get into that later on. And then we're going to go into the question mark z, and it's going to tell you the same thing. It's going to tell you the Python object type, what's the data type, everything. And this is very short. It's going to say float, so it's a float, string form 10.7 because it is, and then convert a string or number to a floating point if possible. And yep. So let's get into the next one. Right here we have y plus 7. And like we talked about earlier, you can add an integer and a float. But if you add an integer and a float, they're always going to come out as a float. So right here, that's what we did. We did 10 plus 10.7. An integer plus a float, and it came out as 20.7, a float. And in order to check it's a float, yes, you can see it's a decimal type, but you can also do type by doing here. Type in parentheses, boom, and it shows us it's a float. Plus 7. The Python integer and float object types can interact mathematically since they are both numeric. That is true. These are both numeric numbers. But here we run into a little bit of a problem. X plus y, a string and an integer cannot due to a Python type mismatch. See right here we get a type error, and it shows us that the problem is right here on line 1. And that is the problem because a string and an integer cannot interact mathematically because one is numeric, the integer is numeric, but the string is not. But there is a way where we can convert a string to an integer. There is a way, but for this we cannot because it's cat, and you cannot convert cat into anything because it's a bunch of characters. There's no numbers in it. So they're both, one's a numeric, one's not, so they're not compatible. And as you see right here, it's a type error because they're two different types. So let's go into the next one. The final Python object we will cover in this video is a list. A list allows us to group other Python objects such as strings, integers, floats, and more. Let's create a list and check out its object-oriented programming methods. Okay, so we're going to check out some methods using the dot notation again, just like we did with dog earlier with the string. So right here, we have a list with dog, 10, and 10.7. The really great thing about list is you can have multiple data types, which is really amazing. Here, it's not all one data type. We have 3 different data types. We have a string, an integer, and a float. And see when I do shift enter, nothing happens. And when we do type, it comes out as a list. Because you know it's a list because of a bunch of different things. Square brackets. If it's enclosed in square brackets, that means it's a list, and it's separated by commas. So each value is separated by commas. So we go here, shift enter, boom. Now, we're going to hit the tab key to see all of the methods available to this list object type. Select the append method and add the string object horse to the list. So here we have the dot notation again. We're going to hit tab, and boom, we get the pop-up window with all the possible methods. So right here, there's not as many possible methods as there were with a string, but there's still a good amount. And here, the comment says right here, select the append method and add the string object horse. So we're going to do type A, tab it out, boom, appends right there. And we want to add the string object horse to the list. So what this is going to do is it's going to add the string horse, H-O-R-S, to the end of the list right here, to the end of the list. So instead of 3 objects, there's going to be 4, and horse is going to come out right here at the end. In order to add that, we do dot append with the parentheses, but we cannot just do the parentheses. If we do just the parentheses, look, we get an error, we get a type error because it says append takes exactly 1 argument and 0 given. This is where you put the argument right here in the parentheses. And what's the argument we want to give? It's horse, because we want to add horse, or we want to append horse to the list. So that's what we're going to do. So we type in horse here. And what it's going to do is .append is going to add horse to the end of the list. So right here, this is exactly what it just did. It added horse to the end of the list. And we called it the name demo list right here. And we got that question mark in front of demo list. And this is going to show us what it did for the variables above. And it's going to show us the data type and everything like that. And when we say type, when we say object-oriented types, data type, stuff like that, that's what we mean. They're basically the same thing. We mean that they're strings, integers, floats, lists. There's many more data types that we'll go over later, but those are the 4 that we covered in this notebook here. But let's check it out. So the question mark is going to give us an in-depth description of what demo list is. And that's very courteous of IPython. So let's see what it is. Boom. And it gives us, the type is a list. It shows us what's in the list. So it's dog, the string dog, the integer 10, the float 10.7, and then another string horse. And then the length is 4 because there's 4 objects. 1, 2, 3, 4. That's really great. You can just exit here. And that concludes this Jupyter Notebook. Great job in completing this Jupyter Notebook. In this notebook, we explored some of the fundamental characteristics of object-oriented programming as they relate to Python. By being literate with this concept, it will make it easier for you to use Python as a data science analysis tool. With the fundamentals of Python and object-oriented programming covered in this notebook, you will be ready to advance onto the next steps in our data science journey. Exploring Python basic data types, string, integer, and floats, grouping Python data types with lists, using built-in Python functions and methods, importing your first Python data science library, NumPy, exploring NumPy arrays for data science, combining NumPy arrays with the Berkeley Data Science Library, visualizing data with Matplotlib, introduction to Pandas, the world's leading data science library, Linux, and Git essentials. Each of these topics builds upon each other. Feel free to jump ahead and explore any of the topics in any order you wish. Utilize all of these resources of Jupyter Lab in your entire Collaborate remote desktop environment. We've gone over some of these 9 things. We've gone over methods and Python, but we still got a bunch left to learn. But don't worry. Like I said, if you ever get lost, you can skip behind in the video, pause the video, go ahead, go at whatever pace that you would like. And if you have any questions, you know where to find us. Shoot us an email at abcaslow, CASLOW, @berkeley.edu if you have any questions.